For the first one, what would you do first to solve? Yep, add 4. You get 2x equals 12, and then what? How would you finish it? Divide by 2. So you get x equals what? 6. Yep. Okay. On this one, what would you do first? Yep, distribute. So it's 2 times x. 2x, and 2 times -4? -8. Okay, and then there's no like terms on either side separately. So then what would I do? Anybody? Not yet, no.
Add 8.
Not yet. Yeah, so like do the x's first. So minus x minus x was 2x minus x. Yep, just x. Okay. And then what? So you get x equals 15. Good there? Yeah? Okay. All right, so we are doing equations today, but we're doing equations that have radicals in them, so they're like square roots in the equations. So your objective is students will be able to solve equations containing radicals and identify extraneous solutions. Okay, so some of these are going to be no solution. That's where the extraneous solutions thing comes into play. But it's not going to be like how normally we get no solution, where like when we're solving, like something happens where it, like everything cancels out. You're going to get an answer. You'll get a solution, but it'll be extraneous because when you plug it back in to check it, it won't actually work. Okay, so it's going to be like a number that's acting like it's a solution, but it's actually not. So I'll show you when we kind of get there. So we talked about yesterday what the inverse of a square root is. So what's the inverse of a square root? Like how do you undo a square root? Huh? Square. Yep. So power of 2, right? So when we're solving equations, to get rid of a square root, we're going to raise it to the power of 2, and that's going to like cancel out. You have to make sure, though, that you get the square root by itself first. Otherwise, anything like this, anything not underneath the square root, you'd have to square, and that becomes really complicated, okay? So first get the square root completely by itself on one side, then square both sides to get rid of the square root, and then you'll be able to solve. All right, so let's just go through. Let's do this one to start. So is my square root by itself on this side? Is there anything that's not under the square root? On this side. Is there anything that does not have the square root over it? The 7, right? So get rid of that first. How am I going to get rid of the 7? Yep, minus 7. The square root of x equals 9. And then once the square root is by itself on that side, to counteract the square root, you're going to raise both sides to the power of 2. And then anything with a square root, they basically cancel out. So this side, you would just leave x. Anything that doesn't have a square root, you'd actually square. So it's 9 squared. 81. Yep. Okay. So, and then a thing with this is that some solutions are going to be extraneous. So you'll get an answer just like that, but if you plug it back in, some of them won't actually work and your answer is actually no solution. Okay? So we're going to have to do checks on this, but I'm going to also show you partway through how to avoid having to do the checks, like what to look out for to know it's no solution, okay? So when we plug it back in to check it, go back to the original, and then plug in the x. So square root of 81 plus 7 equals 16. What's the square root of 81? 9 plus 7 equals 16. Does 9 plus 7 equal 16? Yeah. Yes. So you know that that's your answer and you're good. Okay? If it didn't check, then you basically cross that out and put no solution. Okay? All right, you guys try the next one. Go good? Okay, so what do you guys do first on this one? Yep, add 5. Radical x equals 3. And then what? Square both sides. So what does x equal? 9. And then check it. So you get 3 minus 5 equals negative 2, which works. Very good. Okay. Good? So far? Okay. Let's move on. So then you're going to have ones where you have radicals on both sides. In this case, everything might be under the square root. Sometimes everything might not be under the square root. But when you have radicals on both sides, you just have to start the problem by squaring both sides. Okay? And in this problem, since everything is under the square root, all that's basically going to happen is the square roots just go away. So you'll have 5t minus 11 equals t plus 5. Okay, and then what? Yep, minus t. So what's that going to be? 5t minus t is what? Yep, 4t minus 11 equals 5. Okay, then what? Yep, plus 11. 4t equals 16. Divide. So what does t equal? 4. And then you'll have to check that. Okay, so that's radical 9 equals radical 9, which checks. And then go ahead and move on to the next one. All right, so on this one, square both sides. So the square roots just go away. 7x minus 4 equals 5x plus 10. Okay, then what? Yep, minus 5x. So you have 2x minus 4 equals 10. Okay, then what? Yep, plus 4. 2x equals 14. So what does x equal? 7. Yep. And then check that. Okay, so that's 45. Yeah, so that checks. All right, any questions so far? Okay. All right, next one. All right, what do I do first on this one? Yep, subtract 8 to get the radical by itself. Okay, and then now that the radical is by itself, what do I do? Square both sides. So that's just going to be 3y. And then what's negative 6 times negative 6? 36, yep. Okay, and then how do I finish solving that? Divided by 3. So that's y equal. Okay. And then check it. Square root of 36. Does this one check? No. So this is called an extraneous solution. So it's a solution that is basically pretending to be a solution, and it's actually not a solution when you plug it in and check it. So that's why the way this is taught is that you are going through and checking all your answers so you can catch those. So this basically would not be, that's an extraneous solution. And you would actually say no solution for this one. So this happens basically due to this kind of restriction that square roots have. So can I take the square root of something and get a negative answer? No. Can I take the square root of a negative number? No. So the fact that certain numbers have restrictions because of the square root are what lead to these solutions. Because if you didn't have those restrictions and it was just about the way that the numbers multiplied and added and all of that, then it would work. But it doesn't work because of the rules for square roots. So a way that you can tell that it's going to be no solution and not have to do the checks is when you are at the step where you're about to square it, so the square root is by itself, if your square root equals something negative, you know that it's not going to check and then you could just say no solution. Okay? That's the key. So that's the shortcut so that you can avoid doing all the checks for all the problems. The ones that are going to be no solution are the ones where the square root by itself equals a negative number. Got it? Yes? Okay. If you have questions where you have square roots on both sides, do the check for those ones. Because those ones are like hit or miss. Sometimes they work, sometimes they don't, and there's no way to catch it. Okay? But the ones that are like only one square root, you can not do the check, just look to see if the square root equals a negative. Okay, try the next one. Do you understand how to solve this one? What are you guys doing first for this step? Minus 6, yep. And then what would you have to do to get it by itself? What's this in front? So that's like a negative 1. So think about that. If I replace it, and if you look at it like this, if I had this as my problem, what would you do first? To solve this. What do you guys do first? Yeah, minus 6. Then what? Yep, so you're dividing by a negative 1 to get x equals negative 4. So just pretend like this square root is just a big X, okay? So you're still doing the same thing, subtracting the 6, dividing by the negative 1 on both sides to get that square root by itself. Same way we did here, okay? Okay, can I do this one? Yeah, ready? Okay, so what do we do first on this one? Yep, minus 6. Okay, then what? Yeah, divide by negative 1. So radical 2x equals negative 4. Right here. Since the radical is by itself and it equals a negative, what do you know the answer to me? No solution, right? So you can just immediately go no solution. If the problem asked you what the extraneous solutions were, then you'd want to keep solving to say what they are. So if I were to keep solving this, I would do 2x equals 16, so x equals 8. And that's an extraneous solution. Because if I plug 8 in to check it, it's not going to work. Okay? So you'd actually say no solution for this one too.
If you wanted to check it, how would you check that?
Plug 8 in for that. So 2 times 8 is what?
16.
Square root of 16?
4.
Times negative 1?
Negative 4.
So you basically do like 6 minus 4, which is 2, equals 10, yeah. Or you could honestly just plug it in the calculator. Like plug this whole side in and press enter and see if it equals that. But anytime your square root by itself equals a negative, that's when you know. And that's not the same as, like, so see how on this one, how the problem equaled a negative? Yes? But was the square root by itself? No, so you still had to add 5 over. That's when you decide, right before you square it, okay? All right, so let's do this next one. So we have radicals on both sides now. So I have to start by squaring both sides. A lot of people get tripped up with this 2 and try to get rid of it by like dividing by 2, but then all you've accomplished is now you have a divide by 2 that's not under the radical on this side. Okay, so like either way you can't, there's nothing to do about it. So what you're gonna have to do, square both sides. Anything that has a square root is just gonna stay whatever it is. The square root's just gonna cancel out with the squared. Anything that doesn't have a square root, like this 2, is gonna have to get squared, okay? So this side is just gonna be x plus 22. What operation's happening between the 2 and this square root of 3x? Multiplication. So remember that. So the 2 is actually going to have to get squared. What's 2 squared? 4. And then the 3x, the radical, is just going to go away. So that's just going to be multiplied.
Why would you multiply?
Just because the 2 was originally being multiplied to the radical. And then what's 4 times 3x? Yeah, 12x. Okay, then what next? Yeah, minus x. What's 12x minus x? Yep, 11x. Then divide, so what does x equal? 2. And again, the ones with square roots on both sides, you just have to actually plug it in and check it because there's no way to catch it. If it's going to be no solution, you just have to actually check. Okay, so that's radical 24 equals to radical 6. You guys have not learned how to simplify square roots yet to see if those are the same thing. You'll learn that tomorrow. So in the meantime, do this in the calculator. So in your calculator, do square root of 24, look at what that is, and then do 2 times square root of 6, look at what that is, and see if they're the same. Are they the same? Yeah? Okay, cool. All right, and the last one.
It says it was like a decimal for 20 to the square root of 24.
Yeah, so as long as it's the same decimal as you get when you do that, then you're good.
Make it the same decimal.
Are you doing are you doing the square root of 6 and then times 2? Oh, you put the two little on the outside, so don't do the, just the normal, yeah, square root of 6. And then times 2. Because the 2's out front in front of it. Because what's happening is you're putting the 2 there like you're supposed to, but you're using the wrong square root. You're doing the x on the outside, so it's putting the 2 that's supposed to be in front as like the little index. So you would, to fix what you did, do a 2 and then another 2 and it'll fix it. No, it's going to make it 22. Do 2 times and then what you did.
Yeah.
Okay, so on this one, how do you start? Anybody?
Square both.
Square both sides. What is the only thing that's actually going to get squared? The 3. So that's going to be 3 squared is what? So 9 times 4x equals 16x minus 20. So that's 36x equals 16x minus 20. Okay, then what do I do next? Yep, minus 16x. So you get 20x equals negative 20. So what does x equal? Negative 1. Okay. Okay, did you guys try to do the square root of negative 4 in your calculator? Non-real number. Yeah. So think about it. When we're taking the square root of something, we're trying to find something multiplied by itself to make that, right? If I have a negative number, am I ever going to have the same thing being multiplied to itself to make a negative? What's a positive times positive? What's a negative times negative? Positive. So are 2 of the same number being multiplied, is that ever going to be negative? No. So can you take the square root of a negative? No. Okay? So this is also no solution, but this is not an extraneous solution. So this is no solution for a different reason. It's no solution because, well, and it's not really even no solution. Do you guys remember at the beginning of the year how we did the real number system, and we did like where you had to classify the numbers? It was like real, rational, irrational, integer, whole number, all that. Do you guys remember that? So the reason why it's called the real number system, because there are imaginary numbers. And you're going to learn it in Algebra 3-4, okay? So the imaginary number is the square root of a negative 1, which you guys will work with a lot. It just becomes a thing. That's just normal. So this does technically have solutions. They're just not real solutions. They're imaginary solutions. Okay? So technically we say that this is no real solution. But honestly, at this point, I'm happy if you plug it in, see it doesn't work, and you just say no solution. I don't need you to know that it's just not real. I don't need you to know this is any different than the other no solutions, but just so you kind of have that going in your brain for when you get there, okay? Mm-hmm.
Is that because it was squared to the negative?
Yeah, it's because technically it works. If I could make that a 2, that's 6, could make that a 6, it would work. It's just the fact that you can't take the square root of a negative.
So
Yeah.
It just equals nothing.
Yeah, so technically this is 6i on both sides. I standing for imaginary. So like it is equal, but you'd have to know the imaginary numbers to be able to check it and get that it's equal. Yeah. Question? No? Okay. Question? Okay. So this will have a solution once you get there and you learn that, but right now it doesn't. So that's why we say no real solutions. Okay? All right. Here are your lesson check. Bust that out real quick. And then you guys, a lot of people finished the math Excel today early too. So you could probably get everything done. Okay, are we ready for the answers for these? Yeah. Okay, so you should have x equals 12, r equals 3, and no solution. And this one's,
How do you do number 2?
So you'll square both sides but make that a 4, and then you'll distribute that to the r minus 1.
Oh, you distribute.
Yeah. And then number 3 is no solution for a different reason also, because the x's cancel out. Okay? So you wouldn't have extraneous solutions on that one either, it's just no solution.
You distribute, and then you have r plus 5.
No, 4r minus 4.
Yeah.
Oh, r plus 5 equals 4r minus 4, yeah?
What'd you do? Minus 4r.
I would do minus 4r, yeah, and make that negative 3r. And then minus 5 and make it negative 9. So r equals 3.
Then how do you know that number 3 is
Because when you go to solve it and you do minus x, both x's cancel out.
yeah.
So that one doesn't have extraneous solutions, it's just no solution.